Do you have any class at 6:30? After 6:30?
No, sir.
Okay, those who were not able to attend the previous classes, I have shared a link of playlist. Like you can watch all the videos together. Just check the date which you have been attend and watch it. Obviously, it will be boring if you watch it. So you can make it at 2x, 1.5x. Watch it together so that you can have all writing material. Okay, so yeah, it is not writing. Electric current. What is electric current? Rate of flow?
Rate of flow of charges in a
Exactly.
closed circuit.
Exactly. Rate of flow of double of charges in circuit. Or let's write rate of flow of charges in short. That is electric current. Now, why we are mentioning that in a closed circuit? What is the reason behind that? Why closed circuit? Yes? It's open question. Anyone can answer. Why we are mentioning that we required a closed circuit? It's common sense. Come on, tell me.
The current can't flow in open circuit.
Obviously, if there is a break in circuit, if the key is open, yes? You're saying something there?
So if the circuit is not closed, it can't. The current can't flow.
Okay. Yes. Correct. Yes, Harini?
The electrons will be passing out, sir. It won't actually give to the object which we connected there.
Yes. So for making a flow, it requires closed and continuous path. Very simple thing. There is no big deal here. So, and what is the direction of flow of current?
So from positive to negative.
Let me mention conventional current.
So from positive to negative.
Yes. Correct. For conventional current, actually there are two types of current. One is conventional and one is electronic current, which we are saying through electrons. Rate of flow of charge or rate of flow of electrons, both are current, flow of current. I didn't write a flow. Direction of flow of current, if I draw here a circuit, छोटा सा circuit, this is I, which is conventional flow of current. Now, electronic flow of current is opposite E. It is
From negative to positive, sir.
exactly electronic flow of electronic flow of current. That is conventional flow of current. But why we have two things here? Why we have like current flow, electronic current flow different? So this is an open question. Anyone can answer. Right, wrong, doesn't matter. Yes, people, tell me. Why we are having two currents here? Current is current. Flow of charges. But why we are having two direction, different direction of currents?
Sir, maybe like Current, or can I say electricity, is flowing from the positive side to the negative side, whereas the electrons flow from the negative side to the positive side.
Okay. Not likely, but okay. We'll try it. Anyone else want to try something? I don't want silent people. I want answers. Yes, people, answer. Quick. Whatever's coming in your mind. Throw
So
it.
maybe same, sir.
Maybe.
Same as Mohit said.
Okay.
Yes, sir. Even I have the same answer as Mohan.
Okay. Okay. Then let me tell you one chota story. Actually, it's not story. Yes. Somebody's trying something here. Yeah. Speak up.
Yes, sir, same answer.
Same answer. Okay. So this was an incident happened. Actually, what happened? When this current and all that they found that electrons flow, they assumed that this is the actual flow of current. But till then, they don't know direction of current. Sorry, electrons. They assume, okay, current is the direction of this. It will flow from higher potential to lower potential. That's what they are assuming. Higher potential means positive terminal, negative terminal. But when they actually found that electrons are moving from this negative terminal, they start from negative terminal and terminate at positive terminal. How we get this positive here? See, if we were discussing before, when something is given, it becomes what? Negatively charged, right? The similar way they found the direction of electron as this. So they named it as, because they named it as electronic flow of current. But actually conventional by we are saying, so that for our convenient, we have used this one till many years, so we will not change it. So our convenient is conventional flow of current. We have assumed this direction, so we will keep on this because whole world was using this one. Then again, suddenly someone come and say that no, this is not actual flow. This is the actual flow is this direction. Then obviously all theory will go wrong. So they gave a separate name for this one, that is electronic flow. Actual flow is this electronic flow, but conventional we will use. In every question we will use conventional flow of current. That is only an incident happened. That's it. There's no big deal here. Yeah, there's no lecture, no drama thing here, but this thing happened. So they made it as conventional flow of current. This I is a conventional flow. Okay. I'm not able to scroll it. Okay.
Sir, can you define electronic flow of current, sir, once?
It's not, there is no definition for it actually. It is same as a flow of current, but we can say flow of electrons.
Okay, sir.
We can say a flow of electrons, and here we can say flow of charges.
Yes, sir.
There is no exact definition for anything.
Okay, sir.
Okay. So I equals to Q by T. Right, we know this formula. We started with this one. What is I?
So I is current.
Yes.
Current.
Very good. And let me ask some particularly person like someone random here ask. Bhargav, are you there?
Yes, sir.
Super. So what is the unit of current?
Unit of electric current is amperes.
Very good.
That's SI unit.
Exactly. So Satvik, are you with us? he's typing. अच्छा ठीक है. Sai Charan, you?
Yes, sir.
Super. So what is Q here?
So the charge.
Charges.
Charges. Okay. So Satvik, you can answer now. Okay, so tell me, like, what is the unit of charge?
Coulomb.
Coulomb.
Wait, guys. Satvik. Okay. Coulomb. Yes. Super. So do you remember the chota unit of charge? Anyone can answer this. Chota unit of charge or a CGS unit of charge?
Ampere.
Okay. Let it be. You can tell me later if you remember that. Now we have one more formula, that is Q equals to NE. What is N here? Anyone can answer. Quick. What is N here? Do you remember?
Number of electrons.
Very good. Number of electron. And E is
The charge.
charge of one electron. E is charge of one electron, N is the number of electron. So if I substitute here, and E by T, I equals to NE by T. So we got one more formula. So how to define 1 ampere unit of charge? 1 ampere equals to 1 C by 1 S. So this was our first class, if you remember that.
Yes, sir.
What is 1 ampere? Define 1 ampere.
Sir,
Yes.
sir, A is the unit of I, sir.
Yes, A is a unit of I. Yes, correct. But I want.
Sir, can you tell its full form, sir, once?
Sorry. What did you say?
It's full form, sir.
Ampere. Ampere. 1 ampere equals to 1 coulomb for 1 second. These all are units of these people. Okay. So these units are most important. You have to remember units and notation. I is the notation for current. And current unit is ampere. Ampere notation A. Okay, don't get confused. Don't get mixed up with this. I is the unit of current. And A is the unit. Sorry, I is the notation of current. This is current. This is charge. Time. Time unit is second. And how we denote this? By S. Charge unit is coulomb. It is denoted by capital C. Okay, don't get confused with these things. Okay. Now I was asking you a definition of 1 ampere. How do you find this? Yes, somebody wrote something. Yes, very good. Great. Super. I wrote this before also. Again, remember this again. 1 coulomb of charge flows in, or we can say flows through given cross section of conductor in 1 second. Somebody wrote something. Yes. Yes. See, Yukta, what you define is ampere. That is ampere. I'm asking single ampere, 1 ampere. When we can say 1 ampere, just what you do? You do remove that amount. You said amount of flow of charge. Yes, that is correct. But that is when we ask what is ampere. Now here, what is the question? 1 ampere.
So is that given through given cross section of conductor?
Cross section of conductor in a 1 second. Then current is said to be 1 ampere. That is 1 ampere. We are particularly mentioning here 1, 1, 1. So let me ask you, what is ampere then? It is 1 ampere, then just I'm asking ampere. This.
Sir, it's a charge.
Then instead of 1, we will say amount. Amount of coulomb, amount of charge, flow, same thing we can write here in given time. That is ampere. Amount of charge flows through given cross section of conductor in a given time. So here we mentioned here particularly 1 ampere. This one. Here, total, like any ampere. It can be any ampere. 2, 3, 4, depends. Okay, shall I scroll down?
Yes, sir.
Bhumika, are you with us?
Yes, sir.
Super. Modita? Modita? No?
Yes, sir.
Nitya?
Sir.
You're with us, right?
Yes, sir.
Super. And Ritvik, you too?
Yes, sir.
Super. Sharanya?
Yes, sir.
Super. Nobody sleeping, right?
No,
Okay.
sir.
You came
Not
from
yet.
school and got tired and like, oh, I'm feeling so sleepy, let me sleep. Sir is not watching. Okay. ठीक है. Next is potential difference. What is potential difference? Simple. Just separate these words. Potential and difference. Difference between two potentials. Potential means points, two ends. So we are saying this two as a potential. Positive potential, negative potential. So difference between these two potential, we are saying potential difference. Simple. So what is potential difference, which is denoted by V, which is work done to move a charge from point A to point B. That means due just now on potential, right? So how much work is done to move a charge from one point to another point? One point to another point. How much potential is? So how much work is done to move charge from this point to higher potential to lower potential? Obviously, if I draw something here, a 2 wire, obviously it will flow higher to lower. Right? there is a high point. Yeah, sure. I will scroll up. This is what we were writing. Sorry. Done.
Done.
Okay. So work done to move a charge from point A to point B, that is called potential difference. So with the formula, we can say work done on a charge. That is our formula. But there is one more thing, which is electric potential. So we don't get confused with these two. Both meanings are same, but in different way. Here we are mentioning between 2 points.
Work done to move a charge from higher potential to lower potential.
Yes, that is your potential difference. So if I say electric potential, means same thing from infinity to a point. To a point B or point A, whatever we have to mention. See, it is like same thing. How we define here ampere and 1 ampere, similar way. Here we are mentioning between 2 points, potential difference. Between 2 points. Electric potential means from infinity to a point. So work done to move a charge from infinity to a particular point, that is electric potential. Okay. Okay. Now, suppose if I ask you one question, if I have two bodies here, and this is isolated system, and there is one rod kept here, gold rod, blue color, and this is hot rod, red color. And this is isolated system. Isolated system means no heat transfer takes place. Okay. So what will happen inside this object? Can someone explain? Anyone? It's open to everyone.
Sir, can you repeat the question?
This is our hot body. Red color is hot body. This is cold body. And this is our black is our isolated system surrounding. So what will happen in this one?
So they'll neutralize maybe.
So I just want to know initially what will happen. At instant it will get neutralized, or slowly it will get neutralized.
So it will take time to neutralize.
So it will go from here to here or here to here.
From hot to cold, sir.
So hot body will what hot body will do?
A hot body will pass the heat into the cold body to neutralize it.
Exactly. So he is ready to accept heat and he is ready to accept cold, so that both will exchange heat.
Yes, sir.
So when something gets colder, when something release heat, it gets colder. When someone accepts heat, means it gets hotter. So when something rejects heat, that means he is losing heat, that means he is getting colder. So this body, he started losing body B, body B started losing heat. That means it started becoming colder, and he's accepting heat. That means he's getting hotter. So as he said, correct, it will get balanced. So in short, what is flowing? Higher potential to lower potential, hotter body to colder body. even in batteries also, which I drew just now. Plus is connected here, minus here. So current flow in this direction. So we can say this is high potential. This side is low potential.
Low potential.
Can you repeat once, sir?
Sorry.
Can you repeat once, sir?
Yeah, sure. Now which part? This part?
Yes, sir.
So current flows from higher, as I drew here. Let me draw this battery again. So this one, in this case, this is higher potential because it's hotter body, and lower potential is colder body. So it's traveling, heat is traveling from B to A. In this one, this positive terminal is high potential, and this is low potential, negative terminal. So current travels from this direction to this direction, our conventional current. Direction of I. So it's travel from higher potential to lower potential.
So always plus will be like plus will be always high potential and minus will be
Yes.
negative will be lower potential. So
Exactly. It will be. It will be like that. That's what our assumption was from the starting. So we are assuming now also same. So we have assumed one potential, that is positive terminal is high potential and negative terminal as low potential. Okay. Clear, Harini?
yes, sir, it's clear.
Now let's go with the unit. SI, unit of potential difference, PD. That is voltage.
Voltage.
And potential difference also denoted by V, and its unit is also denoted by V. Both
V.
are V. Now, what is the formula? V equals to W by Q. So, unit of work done.
Work done by charge.
Yes, unit of work done.
Charge into voltage.
No. Unit of work done. Can someone recall 9th standard?
So work done is in joules, right?
Yes, joules. And few students were already there with me. We studied this work done and all. Right, last year. Who were there?
Yes, I was there.
Yeah, you were there.
I was also there.
It is joules. So work done unit is joules. That is SI unit. Then charge Q unit is, just now we discussed. What is it?
So Coulomb.
Capital C. So if we combine these units, V equals to 1 V equals to 1J by 1C. Can someone make definition of this one now? What is one voltage? How to define one voltage? Similar way, how we define 1 ampere? Similar way, I want 1 voltage. Come on, quickly. You define and write in your notebook and give me answer.
Sir, 1 joule of charge flows through given cross section of conductor in 1 coulomb.
Okay, but actually you give answer as ampere only exactly.
Yes, sir.
But you can try this way, include these people. Because we are writing about potential difference. include those people. We cannot leave them. No partiality. Try again. Aruni.
Yes, sir. Sir, 1 joule of
Of
charges flows from
charging.
point.
No. 1 joule of work done, not charges.
Yes, sorry. So the work done from point A to from point B, something
Exactly. Exactly. That's what the definition is. Shall I write here now? Or anyone want to try? Anyone else want to try? Come on. Quick, Aditi. Aditi, are you with us?
So,
Yes, dear. Tell me. Define this one voltage. Define karo. Just try something. Yeah. No idea? Don't give up too early. Anyone else want to try? Mohit? Ritwik?
Sir, even I have no idea, sir.
Give up too early. Bad. Ritwik, Sai Charan, Satwik,
Yes, sir.
tried?
Sir, trying.
Okay, somebody wrote. Don't give up too early. Okay, I'll write here. Fine. When we can say 1 voltage, when 1 joule of work done in carrying 1 coulomb of charge from, or not from, then across 2 points. Let's mix standard form. Across 2 ends of conductor or potential. Potential difference between two ends. This will be 1 voltage. 1 volt.
So is that potential difference of PD?
Yeah, PD is potential difference. Between two ends would be 1 voltage. So if I just wrote it a bit longer, if I make it shorter, 1 joule of work done in carrying 1 coulomb of charge from one point to another point. That is 1 voltage. Simple. Okay, shall I write question here? Question number, I don't know, whatever it is. 1, 2, 3, 4, 5, 6, whatever it is. How much? work is done in moving a charge of 5 coulomb from infinity to a point A. If potential at A is 20 volt. How much work is done in moving a charge?
100.
Obviously, right? So what we'll do?
20 into 500.
Yes, W by Q. So W equals to V Q. V is 20 into
20 into 5, sir. 100.
which is 100. 100 what? Unit? What's the unit?
100 joules, sir.
So don't forget units. Unit is most important. Who left too early? Sai Charan. Left again. Joined again, left again. Ritwik also? No, he's there. Okay. Next question. Work done in moving 10 coulomb charge from A to B is 150 joule. If potential A is 50 volt, find potential at B. Now see, they gave 2 points. I'll give you one more hint here. If this question was asked in this condition, there is infinity, we will assume infinity potential is 0. Okay. Yeah, we will assume here infinity potential is 0. So that's why we wrote here 20. Actually, it's not 20, it's 20 minus 0. Difference in potential. So 20 minus 0, that is into 5. Clear, everyone? Everyone?
Yes, sir.
Yes, sir.
You heard what I said, everyone?
Yes.
Shall I repeat? Are you understood?
Yes, sir. Once more.
Okay. See here they gave us infinity to a point A. So we are writing 20 as point A because it's given, and infinity voltage we will assume as 0. Because we know we want to know potential difference. V is potential difference. So difference between two
So
potentials.
once can you scroll down to the question?
Yeah, like this. Here we have point A and point B. So we need to find difference in potential.
So 150 minus 50. Is that correct, sir?
I'm sorry, say it again.
So the potential difference is now 150 minus 50. Is it? Oh.
No dear, see this. This is work done. What is the formula first? B equals to W by Q. Right? Now, B is whatever it is, let it be, we will see that. First, find out this 150 by 10. That is 15. So here B minus BA, which is this one, which is equals to what we got here? 15 from this. Now B minus, what is BA? 50. Equals
50, sir. 15, sorry.
That means
So VB is equal to 65.
65 voltage.
Yes, sir.
Okay, understood? Everyone?
So, can you scroll to the questions?
Sure. So what they give? Potential at point A is 50 and find the potential at point B. Tomorrow we will discuss Ohm's law. Okay, shall we have quiz now? Who's ready for quiz?
Sir, I guess
Sir, I
me.
am.
Yes, sir. Already.
Ready for quiz? Everyone?
Yes, sir.
Yes, sir.
Okay. Then just let me arrange the quiz. I'll keep on this electricity itself. Electrostatic. Only one attempt, no power ups, right? Do you need power ups?
Yes, sir, key power ups is going to be better.
Okay. It will be fun actually, power up. Okay, see, I'm sending in chat box. Check it out. Yes. Have everyone received?
Yes, sir.
Super. I want all 16 members, oh, not 16, except me, 15 members to join quickly. In 10 seconds, I want 3, 5, 7, and 10.
Sir, 1 minute.
I don't know counting actually.